I got about 15 minutes before my next classes start, so let's go through and do some homework for, I'll probably give this out Tuesday or Wednesday. You're supposed to write the component form of this vector given its initial and terminal points. And the idea is really simple. If you just add two vectors, you get the resulting vector. At least you get the path to the termination. And sorry, I'm on a different set of notes there. Here we just need to find the change in x and change in y. So the vector is going to be the change in x. We write this as a component form, and the change in y. So to go from 4 to -8, we lose 12. And to go from -1 to 0, we add 1. Same thing. We fell 12 units, we ran 1. There we go. There's the component form. Let's see here. Look at 5. If you can do 5, you can do 3. Write each vector in component form, identify its magnitude and direction. All right, so let's start the component form. We'll just call it vector v. And the first set of parentheses are going to be 9 minus 4. Sorry, I don't know what you actually call these symbols. But the first term in component form is going to be 9 minus 4, and the second one's going to be 5 minus 3. And then we just clean that up. 9 minus 4 is 5, 5 minus 3 is 2. There's the component form. Now we want its magnitude and direction. Well, I mean, there's lots of ways of doing this. If a theorem doesn't pop in your head, you draw it. And maybe, I don't know, you triangle it out. You can do a little Pythagorean theorem. 2 squared plus 5 squared is c squared, your magnitude. That's 4 plus 25 is c squared. So 29 is c squared. So your magnitude is the square root of 29. There you go. The magnitude of vector v is the root of 29. Now, what else you can do is you can just, there's a little theorem that says the magnitude of a vector is the square root of 2 squared plus 5 squared. X squared plus y squared. I did that backwards, sorry, but it doesn't matter. You get the same thing. Now, they do want direction. So now that I have my little triangle here, we'll just call this angle theta. Theta would be the arctangent of 2 over 5. So we go to our calculator, we make sure she's in degree mode, this one is, and we just type in the arctangent of 2/5. Let's go out at least 2 decimal places. It's about 21.80 degrees. There you go. It's not that hard. You can draw or you can use the theorems. The theorem is that the angle is the arctangent of x over y. But there's a little more to it. Sometimes you got to draw. It doesn't always work. I wish it did, but it doesn't always work. Let's see here. You ought to be able to do 9 and 10. If for some reason you can't do 10, I don't know what's wrong with you. But twice this vector would be where you take the individual components and you multiply them by the 2. That's twice a vector. So 9 simple. I'm not going to do number 8 about Yumiko. Here we're throwing a ball. It's thrown with initial speed of 20 miles per hour in a direction that makes an angle of 30 degrees with the positive x-axis. All right, so let me try and draw. That's probably close to 30 degrees. And the grid is just here to help. magnitude will be 20 miles per hour. Now this is vector v, and it's actually made of two components. It's made up of a horizontal component, which I'm calling v of x, and it's made up of a vertical component, v of y, and your job is to find those. You do that with trigonometry. I'm actually going to do it two ways. I'm going to do it using 30-60-90 theorem, and I'm going to use trig. 30-60-90 theorem, the short leg is x, the hypotenuse is twice that, and the long leg is x root 3. So let me take my little triangle here. It's got a 20. To get to the short leg, I half it. And to get to the long leg, I multiply it by root 3. And now I have my individual components. I really, really do. Vector v is the addition of two things. One of them is the x-coordinate here, 10 root 3, 0. And that would be v of x, the horizontal component, plus the vertical component, which is just 10. And that's how you actually form vector v. So there you go. Now, if you don't like these perfect numbers like this, you will never be an engineer because you're relegated to rounding. So there's that. You will never design the next telescope that we scan the heavens with. You will not ever design a vaccine. It's all gone. You get to lead the simple life. All right, so anyways, we can do a little trig too, or we can take what we have. We'll call one of them x, one of them y. Probably label that one x, that one y, because they are the individual components. If I was solving for x, I would do adjacent over hypotenuse, which is the cosine ratio. The cosine of 30 degrees is x over 20, so x is 20 cosines of 30. And then I could just push some buttons in a calculator. This actually takes longer. 20 cosines of 30, and again, my calculator was in degree mode, is about 17.32. If I wanted y, I do opposite over hypotenuse. The sine of 30 is y over 20, so 20 sines of 30 is y. That's 10, which is no surprise. It was 10 up there. Anyways, there's that. I wish you'd learn 30-60-90 theorem and 45-45-90 theorem, but what do I know? Let's see. I don't want to do the plane. I really don't want to do this one because I spent so much time drawing that. But if I don't, I'm going to be asked how to do it. So I'm just going to do it. You are pushing a 350-pound sofa onto a ramp that inclines 10 degrees. I even drew out the diagram that you would need to do this. Find the component form, add magnitude of the vector. There's that word that again. That determines how much force you need to keep the sofa from rolling down the ramp because you don't want to die. And you're finding this force vector right here. It's actually not hard. If you just focus on this little triangle, you want to know what this is? It is opposite of 10 degrees. And 350 pounds is the hypotenuse. So you kind of scroll through SOHCAHTOA. And you have opposite and hypotenuse. It must be the sine ratio. The sine of 10 degrees is F over 350. You need to know how much force you're exerting. It's not going to be 350 pounds. We'll see what it is. It turns out the force you need to push is 350 times the sine of 10. This is an important skill. Important. And they do this. They're supposed to do this in physical science. It is legit supposed to be taught in physical science. It's about 60.78 pounds. Now, they actually want the component form, don't they? You may not have the component form. What you found is there's 60.78 pounds coming back towards you. That's what you found. Pause this real quick. So what you actually found there was the magnitude of the vector that was pushing back on you. Now, because this diagram, these are parallel lines, I drew that down here. They want the horizontal and vertical components of this vector. That's what's being asked of you. So we'll call this one y, we'll call this one x, and we got another triangle down here that happens to be a right triangle. And let's see what we know. If we're solving for x, we would have adjacent over hypotenuse. The cosine of 10 degrees is x over 60.78. So 60.78 cosines of 10 degrees is my x value. This is how it's actually taught too. There's formulas that you can memorize, and they'll tell you how to find the horizontal component. It's always about cosine. It's about 59.86. So if I'm talking about the horizontal component of v, it is that x value, 59.86, and it has no horizontal components, 0. Talking about y, I have opposite over hypotenuse. That's a sine ratio. The sine of 10 degrees is y over 67.8, or 60.78. And then I just cross multiply. 60.78 sines of 10 degrees is my vertical component. And it is 10.55. So my vertical component of vector v has no horizontal component and 10.55 on the y. Now, if you take these decimals, now granted they're rounded, but you square them, oops, and then take the square root of that, we should get the original force vector. We got close, 60.78. That's just how you check your work on it. And that is your homework for 10.3. You're welcome. I'm sorry you have homework, but you're very welcome that I've spent 20 minutes doing a good chunk of it for you. Be grateful, be gracious.